Imagine planting a tiny seed and watching it turn into a full crop you can actually harvest. That's exactly what my group and I will be exploring in this project. And today we are happy to take you through this journey with us. Keep watching. Welcome to our student plot project. For this assignment, our group worked with two crops, corn and cucurbit. In this video, we'll give you a walkthrough of everything we did from preparing the plot to planting to monitoring the crops as they grew. We'll also share some of the challenges we faced and decisions we had to make along the way. Overall, this introduction gives a quick overview of how our plot developed and what we learned from managing two different crops in the same space.
The primary goal of this project was to move beyond theory and give us hands on experience working with real crops under real field conditions. We didn't just study how to plant and manage crops, we actually got out into the field to plant, manage, and observe them for ourselves. This is the difference between reading notes and actually doing the work. It builds practical skills that you can't get just by sitting in a classroom. Corn and cucurbit were provided to us because they represent two very different types of crops with contrasting growth habits and requirements. This contrast gave us the chance to compare and manage distinct crop types side by side, which is crucial for learning adaptability in agronomy. The entire process allowed us to practice and refine several skills, which are our agronomic skills, crop monitoring, pest identification, and management. Finally, we used a companion planting strategy, a traditional and highly effective method. Originally, we were supposed to plant the three sisters, which consisted of corn, beans, and cucurbit, but in the end, we made do with just corn and cucurbit. The corn was supposed to provide a tall structure for the beans to grow and wrap around. The beans was supposed to help with nitrogen to enrich the soil, and the cucurbit was supposed to help with weed suppression and conserving moisture. This combination wasn't just planting two things. It was implementing a strategic agricultural system to maximize our plot's health and productivity. Corn, scientifically known as Zea maize, we specifically grew the Caribbean yellow hybrid variety. It gave us a robust and reliable plant for our observational study. Corn at its heart is a tall annual cereal grown extensively across the globe. It is prized for its long ears that are packed with starchy kernels. These kernels, which are commonly referred to as corn, are essential in several global sectors for food source, biofuel, and industry. From an academical and practical standpoint, corn was an ideal specimen for the project for two main reasons: its growth rate and its clear stages of development. This clear sequential development made corn a superb plant for data collection and for learning how to methodically track the progress of an agricultural product from seedling to maturity. It taught us precision in monitoring and reporting the physical state of the crop. Cucurbits belong to the Cucurbitaceae family, which is commonly known as the ground family. Unlike our single variety of corn, we use a native variety of cucurbit. This is a large and incredibly diverse family that includes many popular and commercially important plants such as cucumbers, melons, squash, and pumpkins. These plants are easily recognizable by a few distinct features such as sprouting vines, large leaves, and yellow or orange flowers.
The bed assigned to this group was of the following size. Lengthwise it was 20 feet or 240 inches, while widthwise it was a foot and a half or 18 inches. The space in between rows was around 1 foot as well. giving enough room to work on and to minimize the struggle of sunlight in between the rows on each plant. So the preparation of the beds is like building a foundation. It's crucial for the crops. To start with, the plot was weeded out. Also, the beds were reshaped since some parts were uneven. In the picture of the beds, you could see that they're raised, and you may ask, why raised beds? Raised beds has its benefits, which is a plus for the crops. These benefits are improvement in water drainage in case of a heavy rainfall, which may occur, and raised beds contribute to germination since the raised soil tends to be warmer, which aids in germination. When it came to plant spacing, we tried to follow this religiously. Sure, minor imperfections were made, but nothing which would be an eyesore. Probably just an inch off, but like I said, it's just minor imperfections. The corn were planted at a distance of 10 inches apart from each other, while the cucurbits were planted at a distance of 12 inches. This serves that gap served as you could call it like a barrier or a borderline so they don't fight for nutrients when it came to growing. To know how many seeds you need, you have to do basic division and multiplication. You need to divide the length of the bed by the plant spacing. In this case, after doing the division, we found out that we need 24 corn seeds per row and 20 cucurbit seeds per row. But for the corn, we're not finished. The bed will have two rows of corn, so we will have to multiply the 24 by 2, which equals to 48 corn seeds. Now that we know how much is needed per row, we need to multiply it by 3 since we are dealing with 3 rows. This equals to 144 corn plants and 60 cucurbit seeds. This is the total number of seeds needed for the plot. When it came to weed management, it felt like a never-ending battle. Like we would have to go and clean almost on a regular daily basis. And when we went back, we would see the majority of the weeds growing again. This implied that we had to use equipment like a machete or a hoe to remove the weeds, but in some instances we had to use our hands. Like in the beginning, the plants were so small and fragile, and we didn't want to risk to damage the plant, so we had to use our hands. While weeding, we observed that there were three weed types. These were sedges, grasses, and broadleaves. Three of them grew, but the one that stood up in abundance would be grass. But when the corn and the cucurbit grew, weeding was something we didn't have to do much on a regular basis, probably like twice or three times a week. Since when the corn grew, it made shade, and the cucurbit it started to spread around. We deliberately started to move the cucurbits while they started to grow so that they grow on the row so that it would cover so it would help with not letting any weeds to flourish under the corn. But at the same time, like I said, we still had to go to remove since they didn't fully cover and still there were still some stubborn weeds that grew.
In this part of the project, one of our main jobs was keeping an eye on the crops every day. We checked the leaves, stems, and overall plant health to make sure there were no early signs of pests or disease. Catching problems early really helped us avoid bigger issues later on. We also used the AESC method to guide our monitoring. That meant looking at things like how strong the plants were growing, what pests or beneficial insects were found, how moist the soil was, and general field conditions. By paying attention to all these details, we were able to make better decisions about what the crops needed and when to step in. Overall, this constant monitoring played a big role in keeping the plant healthy throughout this project. Here I am highlighting three common pests that can cause serious damage to crops. The first one is the armorworm. These caterpillars usually start eating from the bottom of the plant and work their way up, especially on crops like corn. They can spread quickly, so a simple way to control them is by using mineral oil on the corn silk to keep the larvae from developing. Next is the squash bug. This pest mostly affects plants like squash and pumpkins. They feed on the stems and leaves, which makes the plants wilt or turn yellow. A practical way to manage them is by removing the bugs and scraping off their eggs from the underside of the leaves. And finally, we have the aphids. These tiny insects love soft, new plant growth. They suck out the plant's juices and can also spread diseases. Farmers often manage them by encouraging beneficial insects like ladybugs or by using mild insecticidal soap. Overall, these pests may be small, but catching them early and using simple control methods can make a big difference in protecting crops. Here is an overview of how both cucurbit plant and corn plant develop over time. For the cucurbit, it basically starts with the seed sprouting, then the first leaves open up, and from the plant grows pretty fast. After a couple of weeks, the vines begin stretching out, the tendrils show up, and eventually the plant reaches its flowering stage. Once the flowers appear and pollination happen, the fruit starts forming. By the end of the cycle, the fruits mature and are ready to harvest. For the corn, it follows a similar pattern but its own stages. After planting, the seeds germinates, the first leaves comes out, and the plant continues building more leaves as it grows taller. Later on, the stems thickens and the tassels develop. After the tassels, you start seeing the silks and that's when pollinations happen. Then the kernels begin filling out. The ears mature and once the husks dry, the corn is ready to pick. So overall, both crops go through clear stages from sprouting to growing to producing, just at slightly different times and in their own unique way. This brings us to the end of our presentation. Thank you for watching.